Hi. So today is Tuesday, I think, let's call it 11th. And I just wanted to show you a couple of demos. I'm a little not nervous, but I don't know if I can do one. I did it for the first time ever in my life earlier today, and then I couldn't do it right before this. So we'll see. So I want to refresh your memory. I'm going to have you do just a quick little assignment with this where you tell me for each demo two things. You're going to tell me, I hope this is not backward. When I look at the screen, it looks backwards, so I hope you can see it. You're going to tell me what is the medium. In other words, what's vibrating or carrying the wave. And I'll tell you, in most of my demos, it's either going to be glass, air, or water. Okay? What's vibrating? What's the medium? And what's your explanation for the change in pitch? So the idea is that, if you recall, we talked about how high frequency means high pitch, low frequency means low pitch. So here, I just said if we're looking at the frequency is number of complete waves over time. So if I have from 0 seconds to 1, I've got up, down to where I started, there's 1 wave. Up, down to where I started, 2, up, down to where I started, there's 3. 3 complete waves here, 1 complete wave there. High frequency, high pitch, low frequency, low pitch. Okay, so I'll put that there. So my first demo is going to be the one that I maybe can't do. I have always had students who can do it. So if you can do it at home, awesome. Take a video of it and show me and make me feel completely inept. So here it is. I have straight out of our science storeroom at school, sitting on top of my voters pamphlet, because we vote next week? This week? Soon. I have wine glasses, and you can see I have different amounts of water in them. Now, I hope I've done a good job with this. Let's see. If you can do this and I can't, well, good for you. So, okay, that one, I'm not hearing it yet. Let's try this one. You hear the pitch? It was not good, but it was there, and it's this same pitch. So not the squeakiness. So do you hear that same pitch? That's like a really not great job. Now this pitch should be this. So this should be a low pitch. Again, ignore the, there we go. Ow, faint, but it's there. Do you think that should be higher or lower? Let's see if I can do it. Slightly higher, and it's this pitch. So it's the same if I hit the glass. That's my worst. A little higher. Higher. Why can't I do this one? Woo. Mrs. Volk wouldn't be happy to see me knock over all this water. There. Right by my computer. So low pitch. What am I doing? Higher pitch. Now, you guys seriously are probably able to do this way, way, way better than I can, but that is like my second best ever. So I'm actually kind of proud. but only kind of. So what's the medium? What is actually vibrating when I do this? That was awesome! How about this one? Okay, come on, bad one. So this is my favorite one. The glass isn't vibrating, that's for sure. If you look at the water, is the water vibrating? So when I said the glass wasn't vibrating, I'm talking about like this part of it, but this part of the glass, it is. This glass is what's carrying that wave. And I'm going to kind of give you the freebie answer. The reason this is lower, this is higher, this one is the highest, is because of the water's effect at damping. If you remember back to Fe, the water is making the waves stop traveling through the glass. And so the way I think of this one is not entirely the correct way, but it helps me visualize. I picture like this wave that's trying to go through the glass. Could go this way, right? But the higher up the water is, the less it lets it travel. And so this wave doesn't get to travel very far. This travels more, and this travels the freest. Highest pitch, highest frequency. It gets to wave freely, whereas this one gets damped down by the water. That kind of makes sense? Show me your videos, email them to me, because you're going to put me to shame. This is really I'm lame. I know I am, but whatever. I tried, right? Okay, the next one I can totally do. Oh, and by the way, I showed you this. When I hit the glass with the spoon, it's the same frequency as when I try to make the wave this way. Because in both cases, the glass is the medium. The glass is what's carrying those vibrations. Now, some of you may have done this one. I have all these old ketchup bottles here. Before I even do this one for you, make your prediction. So on the last one, when I changed the amount of water, the more water in the glass, the lower the pitch was. So if I do that same thing with these water bottles, this one has no water in it. This one has a little bit more, and more. So which one should be, I should put a little bit more in this one, right? Okay. A little bit more different? Yeah. Which one is going to be high pitch and which one's going to be low pitch? Well, I'll tell you, the secret to that is what's the medium. So if I'm vibrating the glass, it should be just like the wine glasses. But if I'm vibrating the air in it, then it's not going to be the same. And so if you blow into it, I don't know if I can do the super high one. Okay, so on this one, the lowest pitch one, which one was it? Most water over here or least? So is it low, a little bit higher, 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 higher? Or is it high, low, low, low? You figure that out. And then wherever the lowest pitch is, has the lowest frequency. So on this one, I'll tell you how I think about it. I think about that air when I blow into this. That wave, that sound wave can go all the length of the bottle. This sound wave, it kind of stops at the water. It's like it kind of gets squished up. And since it gets squished up, that changes its frequency. Squished up a little more. So here, I'm blowing with the same kind of energy, but the wave can travel different distances, and that seems to affect its frequency. So when you answer this, tell me, what's the medium? What's vibrating? So when I do this, it's not the bottle. There is no water. That only leaves one thing. What's the medium? What's your explanation for the change in frequency that changes the pitch? Okay, now here's a little different way to look at this one though. If I hit the glass, some of these are harder to hear, and so I'm going to pour a little more water back in here. So it's very different. How is that pitch changing? Which is highest? So when I hit it with the spoon, what is the energy? What's that wave traveling through? It's a different medium. It's no longer this. It's this. Okay, so if I'm hitting it, now the medium's the glass. Tell me why this is higher pitch, higher frequency, lower, lower, lower. Okay, that's your job. Whereas when I do this, the more water in it, the higher. So when I blow, the more water, the higher the pitch. But when I hit the glass, the more water, the lower the pitch. Okay? Next one. This one, for those of you who don't know me, turns out I'm dorkier than you thought. And so I'm going to look completely dorky. The way I've done this in the classroom is different, but I have a puppy and another dog here, so I have to be a little neater. And I'm going to pause you for a second, make sure my puppy's not misbehaving. So only a minor bit of misbehaving, not bad at all. So I'm going to take, this is a plastic straw. I don't know if you can get them in Washington County anymore, but I happen to have had some in my science box from school. So I flattened one end of it. I'm sorry, my puppy is drinking out of the wine glass I set on the floor. She's classy. So I'm flattening one end of it, and I'm going to cut this end into a V. Okay, so I have a nice little V here. And when I blow through it, and this is where I look totally dorky, trust me. When I blow into it, you should hear it make a sound. And when it's long like this, it's harder. Just so you can see the effect on my puppy. Oh, she didn't like it. She's curious. And here's my other dog. I'll show you what he thinks. Okay. There, neither one is sure this is okay. All right. So when I blow through this, you have to, if you try this, you have to not squeeze super tight here because air has to go through. So you're kind of vibrating this. kind of like an oboe, okay? So when I blow through, the air is traveling. What's the medium? Just said it, 3-letter word, okay? Air is traveling down here, but I'm going to snip off the end of it. And at school, I would just snip, snip, or have somebody stand here and do this while I was blowing. Here, I don't want the pieces to fly because this puppy will eat them. And so we'll see if I can do it kind of neatly. Otherwise, I might have to put it down in between. So keep in your ear memory what the sound was. So you heard this sound when it's long. So what happens as I cut it shorter? What happened to the tone? Higher or lower? If you want to go back and watch that incredible video one more time, you can. The frequency is changing to go with that tone. See if you can kind of guess why. What is happening to change that tone with the frequency? I have only one more, and unfortunately, I'm going to show it to you, but all that you're going to see is me looking like a dork. You're not going to hear it, okay? But, you know, it's okay. I can look that way. So with this, I have a spoon, and it's attached to a really thin little piece of wire. And if I take this spoon and I bang it across the metal part, I have a table in front of me that has a metal edge, and I'm going to take these wires and hold them just right up by my ears and listen to it. Whoa. I'm sorry, just got this caught in my hair, but I know it sounded like that to you. That is totally not what I heard. It's almost like a bell. And so the reason why the sound is traveling up this wire to my ear, and that affects the quality of the sound. On this one, I just have a spoon attached to, and I just tied a knot just to string. And same thing, I'm just going to put it right up here and kind of press it to my ear. Crazy. And then the last one, fishing line. It's a real thick fishing line, and same thing. So it sounds like that to you, right? Cool. So I know you can't hear it. I even have a real thick wire, but I don't have a spoon attached to it. Maybe I could try. So here's the thing. In these, what is the medium? If you can figure out the medium, then really what you're telling me is why the tone changes. And on this one, I don't know if you can even do it because I don't think I can attach. I'm going to have to work on this for my own pleasure. But I don't know if you can give me any explanation until you've done it yourself. So you can try to do it at home. If you have a spoon and a few different things you can tie to it, just listen to it, because the change of the medium, what that wave is traveling through, completely and shockingly changes the quality of the sound. So the sheet I'm going to give you for this is just super simple. Just name the medium. Tell me why you think the pitch changed and include frequency in that. Okay? Thanks. That's it. Nice to talk to you today. Bye.